In this video, we're going to be looking at concave mirror formulae for a virtual image. Okay, so what we're going to do is we're going to start off with the same scenario as we had in question 1, but instead of using a concave mirror, we're going to use a convex mirror. Now basically this mirror is going to have the same center of curvature, and we're going to be finding the same things. So what do we know? Okay, so from the question in question 1, we knew that the distance of the object was 6 centimeters from the mirror. The height of the object was 2 centimeters. The center of curvature was 8 centimeters. And from this, we were to find the focal point, the distance of the image, and the height of the image. Okay, so basically, to find f, we remember that it's half the center of curvature. So as a result, half of 8 will basically be 4 centimeters. Now, the key thing to understand when we're dealing with a virtual image, the focal point is on the other side of the mirror. So as a result, we need to show use a method of showing a displacement on the different side of the mirror. So as a result, we make our focal point a negative. So as it says here, convex, the focal point's on the other side of the mirror, therefore is virtual, and is represented using a negative value. So when we include it in the formulae, we must make sure that f is a negative. Okay, so from here we're going to calculate v. Now remember, v is the distance of the image from the object. So remember that when we're finding v on a convex mirror, it's going to be virtual. So we use the formula 1 over f equals 1 over v plus 1 over u. We know that f is 4, but remember it's got to be a negative because it's virtual. We're finding v, and we know that u from our question is 6 centimeters, so it's 1 over 6. So obviously I take the 1 over 6 to the other side, so I get negative quarter minus negative a 6 will give me 1 over v. So when I combine the two equations, the two fractions together, I basically end up with 5 over 12, or negative 5 over 12. I then have to inverse this, so I end up with 12 over 5. And as a result, v will equal 12 over 5, or negative 12 over 5, which is negative 2.4 centimeters. So what does this mean? That negative 2.4 centimeters means that it is a virtual image, and it's 2.4 centimeters behind the mirror. Okay, alrighty. So now let's find the height of the image. Now in this case, we're going to use just one of the techniques, and that's using the m equals v over u, and then using hi and the ho setup. Now, because it's negative, we don't have to worry because we're dealing with a scale factor. So v is 2.4, u is 6. So the scale factor is 0.4, which means that it's less than 1, and so our image is diminished, or is a lot smaller than the object. So I know that the scale factor equals the height of the image over the height of the object. So the height of the image rearranging is the scale factor times height of the object, 0.4 times 2, which equals 0.8 centimeters. Okay, remember that the negative is not included. So the image is diminished, and as we're dealing with height, it is a scalar product, therefore the negative only shows it's a virtual image. Okay, so I hope this makes sense, and thanks for watching.